Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. We're still in Unit 1, but we're now in Lesson 1.3, and we're going to do our first part of a two-part little sub-series, if you will, on normality. So in particular, we're going to focus on making sure that the data is normally distributed. However, I have to tell you that in multiple regression, this is not necessarily important in terms of having your data normally distributed, having that nice, beautiful bell curve to it. It is critical in other types of analysis involving different types of algorithms, but not for machine learning, or not for multiple regression, as I just mentioned. Multiple regression is very robust against non-normality. In addition, if your sample size is above 200, you shouldn't really have a problem with issues with normality. But it's a common misunderstanding in statistics and in the application of multiple regression that your data, your independent variables, must be normally distributed. The only thing that needs to be normally distributed or spread out is the residuals when you look at the plots, and we're getting a little bit ahead of ourselves. However, for the sake of practice and for learning how to transform data when necessary, I still wanted to demonstrate this. So why don't we go ahead and go over to R now. So we're inside R. And what we're going to do here is we're going to use the data set that we made in the last video, completed data, and we're going to take a look at some of the variables, or some of the features, if you will, that are already identified as causing problems. So to do this, you're going to use the hist function, which hist stands for histogram, to get a visual of the data. So we're going to take a look at salary, and as you can see here, salary is very obviously not normally distributed. It has more of almost like a logarithmic type shape here. There's a term for this. I'm not thinking of it right now. But it doesn't have that beautiful bell curve where you have the nice round up and down like that. So in order to deal with this problem, we're going to do something called a log transformation. If you can see real close here, right here I'm using the log function. It'll change the shape of the data by applying a logarithm to it. So I just type in this information, completed data. I'm going to add a new variable inside my data set called completed data. With the $sign allows me to add the actual new feature of the new column, and I give it the name log salary, and this will hold the results of transforming the actual salary in the data set. So I do this, and then I take another look, and you can see this looks a little bit better compared to last time. So it's much more of a bell shape, still not perfect, but you can see the difference between the two right there. Now, just so you understand what's going on, I'm going to show you how we changed our data set. So this is my data set. I used the view function for this. And then now you can see we have two columns. I know this is very small, but this is as big as we can make it. We have something here called log of salary right here. This is the new column that we just created using the log function. I just want to show that to you. Now, we're down here in line 5, and we're looking at years of service. Again, you can see here, not too many players last 20 years in the major leagues, or 15 years. They all seem to kind of clump together between 0 to 5, and then there's a huge drop-off. So we have the same experience here, where we have this declining slope, that the really steep slope that goes down quickly. And so we're going to use the same log transformation. So you can see right here, I repeated the process, except now I made a column called log_years, and I use the log function right here to transform years. So I press Control Enter to run line 6, and then I want to get a picture of it, so I make another histogram. And again, you can see that it's nice and round. So this was not a very complicated video. The primary purpose was to demonstrate to you how you are able to transform data by applying different transformations. So logarithm is the one we use here, but there's also the square root transformation and many other ways that you can tweak the data so it has this shape. By doing this, you are able to still run your code and get hopefully more accurate predictions in terms of classifying if that's what you're doing, or in terms of numeric prediction as in like a regression situation. So this is just a very superficial explanation of this. There's many other ways that this can be performed, and it's kind of where art meets science in the realm of machine learning and data science. So I hope that this video was useful for you. My name is Darren Thomas, and I am the Director of Educational Research Techniques. Thank you. Take care.